Hi guys, welcome or welcome back to this YouTube channel, IBwontcrushyou, and today we're dealing with the unit circle and radian measure. Problem 1. A circle has radius 8 centimeters. A. An arc subtends an angle of pi over 3 radians at the center. Find the arc length and the sector area. So all we have to do in here is just firstly rewrite our formulas. Our first formula is for the length of an arc, and this formula is in your booklet, and we have to take this formula from the section for HL only, because we are given an angle in radians, and you can observe that this formula, length of an arc in HL section, has radius r and theta, angle in radians. So this is the formula for length of an arc. So now we have to substitute our values. So r is 8 centimeters and our angle theta is pi over 3, so times pi over 3, and it equals 8 pi over 3, and this is 8.38 and units, so centimeters, and we have to find the sector area. So also we use the formula from our booklet, from the section HL only, and this formula is called simply area of a sector. So A equals 1 over 2 times r squared times an angle. So now we can substitute our values. So here we have 1 over 2 times 8 squared times pi over 3, and this is 33.5, of course, centimeters squared. B. If another arc in the same circle has length 12 centimeters, determine the exact radian measure of its central angle. So we have our length, so length is 12 centimeters. We have to determine the exact radian measure of its central angle. So we're looking for an angle, so for the theta, and we know that our radius is still the same because we have the same circle. So we have to substitute everything into our formula for length of an arc. So all equals r times theta, so 12 equals 8 times our angle. So we can divide both sides firstly by 8, so 12 over 8 is our angle, and now we can also shorten our value, so we will be left with 3 over 2, and of course we have values, we have units radians. Problem 2. On the unit circle, point P corresponds to angle 5 pi over 4. A. Sketch the unit circle showing P. So we know that the unit circle is a circle with radius of 1 unit, and it is centered at the origin 0, 0. So let's firstly draw a circle and then show this angle. So this is our circle. Here we have our point P, our angle 5 pi over 4. So we know that we start in here with 0 degrees. Here we have 90 degrees, so pi over 2. Here we have 180 degrees, so pi, and so on. So here we have 225 degrees, so our angle 5 pi over 4. So this is our point A. And now we have to, in point B, find the exact coordinates of P. So we know that when we have to deal with a unit circle, the first coordinates is always cosine of this angle, and the second coordinate is sine also of the same angle. So the coordinates of our point P are cosine 5 pi over 4 and sine 5 pi over 4, and we have to give the exact coordinates, so we have to calculate them. So cosine 5 pi over 4 is negative square root of 2 over 2, and the same as with sine, so negative square root of 2 over 2. C, without using a calculator, determine the angle of the point symmetric to P across the x-axis and give its coordinates. So firstly, let's draw our coordinate system. So we have in here y-axis, in here we have x-axis, here we have center because we start from the origin 0, 0. And we know that here we have our first quadrant, here we have a second quadrant, here third, and here fourth. So you have to remember that, and here we only concentrate on cosine and sine because we have only these functions in this problem. So in the first quadrant, both cosine and sine, they are positive. In the second quadrant, only sine is positive. So cosine is negative, sine is positive. In the third quadrant, both are negative. And in the fourth, only cosine is positive. So sine is negative. And we know that our angle is 225 degrees, so 5 pi over 4. And we have to determine the angle of the point symmetric to P across the x-axis. So our angle, let's take another color, is in here. This is our angle. So it's symmetric across the x-axis. So it will be in here. So as you can observe, firstly our coordinates were negative as our answers. And now our cosine stays the same, so it's negative, and our sine has to be positive. And because our new angle is symmetric, our negative square root of 2 over 2 has to be square root of 2 over 2. So this is the second coordinate. However, we have to give an angle. So our sine of the angle is square root of 2 over 2, and we have to find this angle, and this angle we can find in solver, and this angle is 3 pi over 4. So this is our new angle, and it is also equal to 135 degrees. Problem 3. Let Q be a point on the unit circle such that cosine theta equals negative 3 over 5, and theta is from pi to 3 pi over 2. A, using the Pythagorean identity, determine sine theta. So basically we are given the formula that we have to use to solve this point. We have to use the Pythagorean identity. So we have this formula in our booklet, and it's called identities, and this is the first formula. So cosine to the power of 2 theta plus sine equals 1. So this is our formula. So now we have to substitute our cosine. So in bracket we have negative 3 over 5 squared, and sine for now stays the same, equals 1. So here we can move this value from the left hand side to right hand side. So here we have sine squared equals 1 minus, and negative 3 over 5 to the second power is just 9 over 25, and we have to calculate it on our GDC. So our final answer is negative 4 over 5, and you have to remember that here we have squared, so we have also take the square root of both sides. B. Find the exact coordinates of Q. So because our point Q lies on the unit circle, our first coordinate is cosine of the angle, and the second one is sine of the same angle. So in here we are not given an angle, however we know that cosine of this angle is negative 3 over 5, and sine of the same angle is negative 4 over 5. So these are our coordinates. C. Determine the equation to find where this line intersects the circle x squared plus y squared equals 9. So firstly, let's find our gradient. And for the gradient, we have a gradient formula in our booklet in functions section. So we have m equals y2 minus y1 over x2 minus x1. So we have y, so our y2 is basically minus 4 over 5, and we don't have y1, so it's just 0. We can also treat this point with coordinates x1 and y1 as our origin, so 0, 0, and below we have x2, so our negative 3 over 5 minus 0. So from this we have simply 4 over 3, of course positive. So our function looks like this. And here we have basically 0, so we don't have to write anything because we start at the origin, so at point 0, 0. So our intersection with y-axis is just 0, so our C is 0. And now we have to find the point of intersection between these equations. So all we have to do is just substitute y from here to here. So we have x squared plus 4 over 3x, and of course in bracket squared equals 9. So we have x squared plus 16 over 9, because also we have to raise to the second power diffraction, not only x, equals 9. And now we can type it into solver and find x. So we have two x's, we have 9/5 and negative 9/5. So we have to find y for the first and for the second x. So basically we can substitute this x into one of these formulas. Let's substitute it in here because here we'll have less to calculate. So we have 4/3 times 9/5. So we can shorten our 3 and 9. So we have 12/5. And basically in here we have the same, however negative. So it will be negative 12/5. So our points of intersection are 9/5, 12/5, and the negative 9/5, negative 12/5. Problem 4. A sector of a circle with radius r 12 centimeters and angle theta radians is cut out and folded into a cone. A. Show that the slant height of the cone is always 12 centimeters. So let's draw our circle firstly. So this is our circle. Here, more or less, we have our center. So here we have our radius, and in here, so here we have our angle. We don't know it yet, so we can draw it like this. And our radius is 12 centimeters. So in here, and everywhere from the center to the side. And we have to show that the slant height of the cone is always 12 centimeters. So let's draw our cone. So more or less our cone looks like this. So when we fold our sector into cone, these are our, let's say, arms of this triangle. So 12 and 12. So the radius from our circle forms into slant heights. And let's use another color. This length forms this circle. So they are all the same length. So we showed that the slant height of the cone is always 12 centimeters. And in B we have to express the cone's base radius r in terms of theta. So in our equation we can have only two unknowns, capital letter R and our angle, and of course pi, because pi we treat it as a value, so it will be also in here. So firstly, because we know that this and this they are the same, their length is the same. So length of an arc, we have formula for it, length of an arc, so r times theta. And here we have a formula for the circumference of a circle, so it's just 2 pi r. And we know that this and this, they are the same. So L is the same as capital letter C. So R, and we know that R is 12, times angle equals 2 pi. And here we have to be careful because this radius is radius of this circle, of the base of the cone. So it's no more 12 because this radius is like slant height in our cone. So we know that cone's base radius is capital letter R, so we can substitute it in here, and now we can divide both sides by 2 pi, so 12 theta over 2 pi equals R, so R is just 6 theta over pi. C. The cone's height is 9 centimeters. Find the exact value of theta, so of our angle. So we know that the cone's height is 9 centimeters. So this height is 9 centimeters. So we can observe that this is our right-angled triangle, so we can simply find our radius, and then we can substitute this radius into our formula and find the angle. So we have 9 squared plus our r squared equals 12 squared. So here we just use our Pythagorean theorem. So now we can use solver to solve it. So r is 3 and square root of 7. So now we can substitute it into our formula. So 3 square root of 7 equals 6 theta over pi. So we can just multiply both sides by pi over 6. So here it will cancel out, and in here we have 3 square root of 7 pi over 6 equals our angle. So this is pi square root of 7 over 2, and deduce the arc length of the original sector. So we have to just substitute our values into the formula. So L equals radius, so 12, and times our angle that we already found, so pi square root of 7 over 2. So here we will have 6, so 6 pi 6 pi and square root of 7, of course, centimeters, and that's our answer. Problem 5. Let alpha be an angle measured in radians such that sine alpha equals 1 over square root of 2, and alpha is from 0 to 2 pi. A. List all possible values of alpha. So we can do it either on our in our solver or in the graph function. So in solver you have to just rewrite this function and find alpha. However, in some GDCs it only gives you one answer, so it's better to type it into graph function as sine and angle. So for example, sine x, we have to set the domain, and you have to be careful because we have to have an angle in radians. So in settings you have to choose radians, and then you can find x value by entering y value 1 over square root of 2, and these values will be pi over 4 and 3 pi over 4. So we have two possible values of alpha. B. For each value of alpha, determine the corresponding cosine alpha. So basically we have to substitute these angles into cosine and calculate them. So cosine pi over 4 is 1 over square root of 2, and cosine 3 pi over 4 is -1 over square root of 2. C, show that our identity, so sine squared plus cosine squared equals 1, holds for all these solutions. So all we have to do is just to substitute sine and cosine. So first in our identity equation is cosine, so our 1 over square root of 2 to the power of 2, and then we have two values of cosine. So let's firstly use this one, so 1 over square root of 2 squared equals 1. So from this we have 1 over 2 plus 1 over 2 equals 1. So we know that half plus half equals 1, so it's true. And with using this cosine, we have still the same sign, so 1 over square root of 2 to the power of 2, and here we have negative value. However, we know that everything that is negative and is raised to the second power is positive, so it will be the same. Half plus half equals 1, and this is also true. D, compute the arc length on the unit circle between the smallest and largest solutions for alpha. So let's firstly rewrite our formula for length of an arc from the booklet. So L equals R times our angle. We have unit circle. So in unit circle, R is always 1, and we have to compute the arc length on the unit circle between the smallest and largest solutions for alpha. So the smallest solution for alpha is this, the largest is this one, so we have to subtract from the largest the smallest, so 3 pi over 4 minus pi over 4, so we are left with 1 over 2 pi. So now we can substitute everything, so 1 times 1 over 2 times pi, so it's just pi over 2. And that was the last problem from this topic, the unit circle and radian measure. And if you found this video helpful and useful, you can share the video to your friends, subscribe to this channel and leave thumbs up. And if you have any questions, you can write them down below in the comments or via my mail, that is as always in the description of the video. See you!